Hey guys, welcome to this video lecture series on the subject of polymer science and technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In previous video, we have just started the new chapter of polymerization techniques, in which we have understand why we are need to understand polymerization techniques after understanding polymerization reactions, and what is the difference between reaction and techniques, in which we have discussed there are four different types of the polymerization techniques, and among them we have started the bulk polymerization technique. If you have missed that video, you can find it in the I button over here. Now moving towards the next polymerization technique, and that is solution polymerization. Well, the major problem associated with the bulk polymerization technique was that it is thermally inefficient. The dissipation of heat that is generated by exothermic reaction of polymerization is very difficult with bulk polymerization, and which also increases the viscosity of the entire reaction mass. Now, to overcome this problem, we have come up with another polymerization technique, and that is known as the solution polymerization technique. Well, you can see here on the screen that this method is used to solve the problem of viscosity associated with the bulk polymerization by using a solvent which helps in the heat transfer and reduce this auto acceleration. We have understand what do we mean by auto acceleration, right? A kind of a reaction which is autocatalytic, right? Now both the monomer and initiator are dissolved in a suitable solvent, and the product polymer is also soluble with the solvent. So now you can see here in this image, you can see that I have taken one tank inside which I have dissolved my monomer and initiator in the suitable solvent, right? Let's suppose water is the suitable solvent. Then my monomer and initiator both need to be soluble in this water. Then I will get this homogeneous kind of a solution as you can see on the screen, right? This is the main reason why we are referring this solution polymerization technique as the homogeneous polymerization technique. Now if we supply sufficient amount of the heat, you can see here, now let me just take a pen. If we supply heat to this particular reactor, or we can say vessel, this polymerization reaction will take place, right? And it will generate polymer. Now just recall what was happening in the bulk polymerization. We were used to getting solid product or solid polymer at the bottom of the reactor, right? But now in this case, in this solution polymerization, the product form will also be soluble in the chosen solvent. So whatever your polymer is going to be produced, it is also soluble, or it will be dissolved in this solution. So here at the bottom you can see here polymer will form, right? I am representing this thing as the polymer. Red lines are your polymer. But this polymer again will be soluble in your solvent. So all in all, this entire solution will be in a single phase, right? The entire solution will be in a liquid phase. So we can say that this entire technique is based on the homogeneous polymerization techniques. You can see here this product form. You can see here this product formed is also in a liquid phase. So this is the main advantage of the solution polymerization techniques. Now heat released by the reaction is absorbed by the solvent, and solvent also help to control viscosity of the reaction mass. So now as a reaction proceed, we know that this polymerization reaction is exothermic. So it will generate lots amount of heat, and that heat is need to be dissipated, as is the case of bulk polymerization. So now we have selected a solvent which will also help to increase the heat transfer, and it will easily dissipate this heat generated by this reaction. So the problem of heat transfer is now overcome with the solution polymerization technique. Not only that, this solution will also help to reduce the increase in the viscosity. in the bulk polymerization, we were getting solid product at the bottom. But now in this case, we are getting product in the liquid phase. You can see here we are getting product in the liquid phase. So it will also reduce the viscosity. And ultimately we can easily agitate or we can easily stir this entire mixture. And it will also help in the mass transfer operation as well. So now you can see here that once the desired concentration of the monomer is achieved, the excess solvent has to be removed in order to get pure product. So now once you have produced your desired product, that is your polymer, and you have achieved your desired conversion and yield, you can remove excess of solvent by just evaporation, right? Water will be evaporated at 100 degrees Celsius. So with this kind of method, you can actually produce good quality of the polymer. So this is what about the solution polymerization technique. Now let me just quickly revise this thing. You can see here I have initially taken one tank, or we can say vessel, inside which I have taken my solvent, right? And inside which I am adding my monomer and initiator so that I can initiate my polymerization reaction. But the trick here is that both the monomer and initiator are need to be soluble inside this solvent. So you can see here I have represented this blue section is your homogeneous mixture of monomer, initiator and solvent, right? So now on the application of heat, whenever I will supply sufficient amount of heat, either by mean of some external source or by the radiation, this polymerization reaction will carried on, right? And it will generate polymer. But again, the polymer produced is also soluble in the solvent. And this solvent will also help to control the heat transfer and mass transfer operations. And it will also reduce the viscosity effect, right? Now let's just quickly discuss what are the different advantages of this solution polymerization. You can see here as the major advantage of the solution polymerization is the solvent reduce the viscosity of the reaction mixture and stirring of reaction mass become very easy, which means we can increase the mass transfer, right? So because of this solvent and our product is going and our product polymer is also in the form of liquid state, we can easily agitate or we can easily stir this entire reaction mass, which will ultimately lead us to increment in the mass transfer and which will also increase the reaction rate. Now, the solvent acts as the dilute and aids in the removal of reaction heat. So as we know that this polymerization reaction is very exothermic reaction and it will evolve large amount of heat as this reaction proceeds. So which means we have to continuously remove this heat generated by reaction. And this solvent exactly does that thing. It helps us to remove this excess of heat and allow the reaction to carry forward, right? So now the solvent is actually serving two purposes. It increasing heat transfer and on the another hand is it indirectly increases the mass transfer by reducing the viscosity. The thermal control is easier than the bulk polymerization. As we have already discussed, in the bulk polymerization, the dissipation of heat was very crucial issue. Now in this technique, that problem of dissipation of heat is now resolved by using solvent. So we can say that thermal control of reaction mass is easier than the bulk polymerization technique. The next advantage is that because of proper stirring, uniform mass transfer can be achieved, right? That we have already discussed. The product obtained in a liquid form can be directly used for the application such as adhesive. So the main advantage of this technique is that we are getting product in the liquid form, which means we can directly use this liquid form of polymer in the certain application of the additives. So this was all the advantages of the solution polymerization technique. Now let's just quickly discuss what are the different disadvantages. But before that, let's just discuss this particular image. You can see here this concept of the solution polymerization, in which we are going to take this monomer and solvent in one tank or vessel. Then we are going to add initiator, and on the application of heat, this polymerization reaction will take place. You can see here this polymerization reaction will take place. Now moving towards the end, this polymer and solvent can also be recovered or they can be separated by just application of heat. Once your desired conversion is being achieved, you can remove the excess of solvent by just application of heat, right? So the separation of product and solvent is not that much difficult. We can easily separate both the thing with the solution polymerization technique. Now let's just discuss what are the disadvantages of the solution polymerization technique. You can see here this reduced monomer concentration which result in decrease in the rate of reaction and degree of polymerization. So by adding solvent inside the monomer, we are actually reducing the concentration of the monomer, which ultimately affect the reaction rate of the chemical reaction and which reduces this reaction rate. So we can say that this chemical reaction in solution polymerization is slower compared to other things, right? So we are compromising the chemical reaction rate when we are using this solution polymerization technique. Now, this solvent may terminate the growing polymerization chain, which lead to the lower molecular polymer. So, with the help of solution polymerization technique, we can only produce polymer of low molecular weight because the chosen solvent can easily terminate the long chain of the polymer, or in the simple word we can say that this long chain of the polymer will easily break out and it will arrest the polymerization reaction, right? So the solvent act as the terminator, or we can say that the solvent act as the inhibitors in this polymerization reaction. The next disadvantage is that difficult to remove solvent from the final product. This causes degradation of the bulk properties. So your polymer produced also contains some amount of the solvent, which eventually degrade the polymer and that lead to the compromise in your bulk property of the polymer. So we can say that we are not going to get 100% pure polymer with this type of the method, because some amount of the solvent will always be there in your product polymer. Now the next disadvantage is that it requires separate system for solvent recovery. We have said that we can easily recover this solvent, but we do require some special type of the separating system, and that ultimately lead to the operating cost. Now, the last disadvantage of the solution polymerization is that if the product is need to be used as a solid, then drying is required. So, as we are going to get product polymer in the liquid state, so if you want to sell this polymer in your solid state, then drying is very much compulsory, which also increases one further stage and which also increases your operating cost, right? So, this was all the disadvantages of solution polymerization techniques. These advantages and disadvantages of these techniques are again very important and which are very useful when you want to compare one technique with another technique, right? So with this, we can all easily compare bulk polymerization technique with this solution polymerization technique. Now, let's just quickly discuss what are the application of this solution polymerization. You can see here, because of its good thermal control, it is widely used polymerization technique. So this solution polymerization provides good thermal control, which is largely used for the polymerization techniques, right? Then it is used for manufacturing of polymer which are in the aqueous medium, right? As we have said that this polymer will be in your liquid phase, so such polymer which are in the aqueous phase can be easily manufactured with this solution polymerization techniques. These polymers are polyacrylamide and polyacrylic, right? When polymer is produced by using organic solvents such as polystyrene and PVC. So we can also produce this polystyrene and PVC which are very much essential for the human life by this method. It is largely used to manufacture polyacrylonitrile by the free radical polymerization and that of the polyisobutylene by cationic polymerization. So this solution polymerization is very much suitable for the free radical polymerization reaction and ionic reactions, right, that we have understand in a previous chapter. Now the bulk polymer are also made exclusively by this technique. So certain type of the copolymers that we have discussed in the last chapter are very easy to manufacture with this solution polymerization techniques. So having said that, this conclude this solution polymerization techniques. Now we will discuss the next polymerization technique in the next video. Till then, keep watching, keep learning. Thank you.